Okay, so the point of this video is to show you how to do a draggable line of best fit in Loggerpro and how to use that to do the maximum and minimum gradients. Okay, so you can see this was the experiment. We were dropping a ball, we were varying the drop height of the ball, and we were using a stopwatch to time how long it took to hit the floor. So you can see we've done 3 repeats, we've taken an average here, and we've used the range of data here, okay, to calculate the uncertainty in the value of t, right? So we've got this column here, and there's a range of different values there, okay? But all that means is that when we were doing this particular drop height, okay, there was a bit more of a spread. We were a bit closer to the tails of the Gaussian distribution. Okay, and when we did this drop height, we just got a bit lucky. All right, but as you can see, if you look down this column, there's no real pattern. Okay, it's not like that at low values of S we were particularly low values of T, or at high values of S we were particularly high values of T. It's pretty much a random pattern as you go down there. Okay, so I've decided that my uncertainty in T, I'm not going to choose the biggest one. Okay, I think it's about 0.07 is a reasonable guesstimate of where we're at with that. And in here, I've used 0.07 to calculate the percentage uncertainty in T. Okay, and then because my graph is T squared, okay, I've propagated that by doing 2 times the percentage uncertainty of T. Okay, so that's giving me the percentage uncertainty in T squared now. And if we look in the T squared column, if I double click on the top of the column and we go to options, you can see how I've done that. I've chosen error bar calculations here. Okay, it's a percentage that's in that column, and I've said use the data set in column percentage uncertainty in T squared. All right, so that's where all of these error bars have come from in the first place. All right, now I can plot the line of best fit, which is that button there for the linear fit. All right, but the what I want to do now is okay, so that's going to give me my best fit, and that's interesting because the gradient of this multiplied by 2 is going to give me the acceleration due to gravity. Okay, but that doesn't give me any idea of my uncertainty in the gradient. So to work out the uncertainty in the gradient, we want to do max and min lines of best fit. All right, how do we do that? We go to Analyze and we go to Model. Okay, and I'm going to choose Linear Fit. Okay, and this is just on the graph, which is fine. You can put the numbers in here to get it a bit closer. It doesn't really matter. Okay, and we'll see why in just a moment, right? Okay, so look, this is my manual fit now, right? Manual fit. Okay, so I want to click into this box here. Okay, and I'm going to enable line drag down here, right? Okay, and then I'm going to drag this line. Okay, and I'm going to choose for IB. This is fine, right? I'm going to choose the extremity of this error bar, the top error bar, okay, to the extremity of this error bar over here, right? So this is the lowest possible value that my gradient could be. Okay, 2.9. Now I want to go with what's the maximum possible value that my gradient could be. All right. And I'm going to do exactly the same. Go to Analyze, Model. All right. And choose a linear fit. That's strange. Why is it on there like that? Okay. So I'm going to choose 0 as the intercept, and I'm going to choose 5 as my gradient. There we go. Okay, so that's my next manual fit. And again, I want to make sure that we've got the line drag on there. Okay, and then I could go to this error bar, right? And then onto this error bar. Whoops. Again, it's got a bit crossed over, hasn't it? Oh, kind of need to get this one out of the way first so that I can move this one into position. There we go, that one's in position now. And then I can move this one back over into position like that, right? There we go. Okay. And I mean, you could make the argument, why are we believing this error? Why are we believing this point here? It doesn't seem to fit the pattern as well. So you could make the argument that we could go with the extremity from this error bar here, right? Okay. And there we have the maximum value of the gradient that we've got, okay, and the minimum possible value of the gradient that we've got, and also our best guess at the gradient as well. Okay. All right. Hope that was useful. That's how you do max and min lines of best fit in Loggerpro.